All right, hi everyone. Thanks for coming today. Sorry we got started a couple of minutes late. So today we'll continue off what we were working on last week with classes and connecting classes with each other. So we'll introduce something called inheritance today, which is how you can use superclasses and subclasses. We'll explain what all this is today. Before I get started, are there any questions on any Java-related topics or anything?
How many classes do we have left?
So we have this week, and then next week will be the last class.
Okay.
And that'll be for all of them, for even including web design, Python, and entrepreneurship. So if you missed last week, I'm not going to review everything, but I'll still explain everything that I'm typing. So if you guys missed like a week, the video is posted online for you guys to watch. So I'm not going to review everything again, just for one person, obviously. So yeah, so just watch that video if you missed last week. When is the Pitch Fest? I don't know off the top of my head. Let me check real quick. It should be second or third week of June. Okay, I don't want to spend too much time looking, but yeah, if you guys have questions about that, just ask in the Slack channel, or you can email Amit. He'll have all the answers about that. Yeah, June 20th. It looks like someone got it. All right, so let me share my screen. Okay, so I'm just gonna start out by creating a class called one.java. So today we're gonna introduce a concept called inheritance or polymorphisms. If you guys have taken AP Computer Science in high school, then you may have some background on this topic, but it's a pretty complicated topic in programming, especially in object-oriented programming. So I'll start out with just creating a class, and I'll call this one. So these class names will be pretty simple today. So the main idea is just to make you guys understand what this concept is. And then next week we'll get into a more real world topic, like an actual topic that you can use to code. But this will be a pretty simple example, just so you guys can get the hang of everything. So I won't include a constructor for this because it's not really needed for what I'm trying to explain. But I'll start out by creating a couple of methods. So we'll have one method that just says, I'll just print out hello. So then I'll just do system.out.println hello. I'll create another method called print by, and then we'll print that out as well. Oops, we got a semicolon up here. And then I'll have one that returns an integer, and it'll just return a 1. So this name, our class name is 1, so we'll just return a 1 here. So this is kind of what we reviewed with last week and how you can create a class, and then you can have all these different methods. So for example, this is a public method that can be accessed if I create a one object outside the class. And then a void means that it will return nothing. So this method won't return anything, but you see here I specified int so that we know that this method will return an integer. So that if you ever call a method that returns something like an integer or a string or a double or anything, then if you were to run that method, it won't really print it out for you, but it will just return that, and then you'll have to print out what the value manually. But in this case, since it's a void method, I'm already printing out. I don't need to do anything else to call it. But yeah, so I'll just create a main.java so I can run all of this. Public class main. So this will just be my main method that I'm using to create these objects. So for example, this is a 1. So what I'll want to do is just create 1, and I'll name this 1 is equal to a new 1. So remember, this is how we create objects in Java based on a class that we create. So I created this whole class 1. It has these 3 different methods. So when I create an object that basically represents everything that is inside that class. So now if I wanted to print out, what did I name my method? Print hello. Oops. I can call that. And then now remember, when you are trying to run multiple files in Java, you can do Java C1. That will compile it, basically. So if you guys see when I run this Java C let me find it real quick. Yeah, you see one dot class is also created when I create a, when I run Java C on a Java file. So that dot class basically allows me to use that file in another file. So now I can run Java main, and then it prints out hello. So this is just a very quick review of what we did last class, accessing methods from other classes, creating objects and all that. But yeah, so I was able to print hello, and then I can print bye also. And then I'll do system.out, or I'll just, yeah, system.out.println 1.1. So that will just call this method that returns a 1 because it's our 1 class. And then if I run all of that together, remember before I run it, we have to compile, and then I'll run it, and then I get all 3 of them. So I get hello, bye, and then 1. So these are just all the methods that I defined. So this is pretty simple in creating a method like this. So now there's something called a superclass and a subclass in Java. So in this case, this is just normal class or anything. But now if I were to create another file, so I'll name this 2.java, public class 2. So this is how you normally would create a class. So for example, if I want to create this class
number
2, but yeah, it's the number 2. If I wanted to create this class 2, but sort of use these methods from this class 1, so basically treat 1 as like a parent class so that I can access different methods in 1 in my class called 2. So the way that I can do that is, so one thing that I can do is I can define this again, public void print hello. Actually, before I do that, I'll quickly just make this. So it's just how we created public int 1 to return a 1 here. I'll create a public int 2 to return a 2. So this is just another class. And then if I want to be able to access all of these methods in this class 1, I can add something at the top of my class header called extends1. So this is basically telling Java that I'm creating this class 2, and I want to be able to access everything that is included in this class 1, and basically extend everything that is in that class. So I can access variables, methods, if they're declared public, obviously. And then now you see that in my class 2, I'm extending 1. I only have 1 method in here called 2. So now if we go back and I create another object called 2, then I can call these same methods again, print hello. I'll just copy and paste it to make it a little bit quicker, and print bye. Yeah, so I'll call print hello, print bye, and then obviously we have 2, which is what I defined here. So this should print out a 2, and then these should print out what happened last time. So remember, I'll have to compile both of them. So I have 1.java and 2.java. So I'll compile both of them. And then I'll run this main. Oops. And then you see hello, bye, 1, hello, bye, 2. So basically, 2 was able to access these methods print hello and print bye from this class 1. And it basically just took whatever I defined in this class 1 and did exactly what is defined in class 2, even though I didn't create these methods in 2. So that allowed me to use these methods from other files. So another thing that you can do is if I name this the same thing, void print hello, then I can just call super dot print hello. So this is basically saying I'm going to take whatever the current definition of print hello is in my superclass. And in this case, my superclass or my parent class is 1. So 1 is the parent class, and I'm taking all of that. And then I can just add another print statement. And we'll just say hello world, for example. So now, I'm basically taking my original, what this is doing is taking my original definition of print hello in 1, and then I'm adding another print statement so that when I call print hello on an object with 2, so how I'm doing it here, then that will basically add to the output. So once again, you want to compile everything. And then once I run it, I get hello by 1, then hello world by 2. So if you see that, I added a world. So we have hello and then world, so which would happen when I called print hello. Yeah, I'm just naming these 1 and 2. That doesn't really mean anything.
Can you please go back to main.java?
Yeah. So notice how the output of 2 changed when I called the superclass and then it added to an output of it. And then same thing since
excuse
2.
me?
Yeah.
So when I type in 1.print underscore by, or when I type in 1.1, the 1 is not coming in plain white letters. It's coming as italicized blue letters for some reason.
Is the O capitalized in 1?
Yes, yes. No, I mean, no, it's not capitalized.
Okay, yeah. So just make sure it's like this. So you see 1, if it is in the italicized blue letters, that means it's probably thinking it's like a class or whatever. But since I made this one lowercase and it's just like a variable name, then I'm able to access it like that. So sometimes also like these applications will like italicize certain words you don't want it to. But if you just run it, then you can kind of see what's happening. You can see why it's italicizing it, or you can just see if there's an error or something. So just after you run it, it gives you like a pretty good idea of what the problem is.
Oh, I see.
So yeah, I will quick explain superclass again. So think of 1 as my parent class that has all my function definitions. And then 2 basically extends that parent class 1 or superclass. And then 1, if I extend 1, then that allows 2, this class 2, to access everything. That was created in this class 1. So now if you see here, I can, as I showed before, if I just don't include this, I can still call print hello from this class 1 and it will do whatever is defined there. But since I defined print hello here, it basically called the super version of it, which is just printing hello, and then I added another line to print out world. So then when you see when we ran 2, then it printed out hello world like that.
Excuse me, could you go back to 1.java just for a second?
Mm-hmm.
Can you please go back to Java 2?
Yeah, so all this code will also be posted online, but yeah, are there any more questions about this? I know I went through that pretty quickly. So yeah, I'm still getting some questions on what super is. So super, so I keep saying the words parent class, superclass. Those are basically the same thing. So super basically allows me to access whatever function definition was created in that class 1. So super.printHello, it automatically understands that, oh, it checks what is my superclass, and it sees my superclass, it sees this class is extending 1. So now it knows that 1 is my superclass. So then it goes super.printHello. So now it finds that class 1, it goes to my class 1, and then it finds the definition of print hello, and then it sees that it just prints out hello. So basically, if calling super.printHello is basically the same thing as taking everything that is inside this function and putting it here.
If we make it so that it's class 1 extends 2, does that mean 2 is the superclass?
Class 1 extends 2. Yeah, then 2 would be the superclass. But in this case, like, since 2 is basically using definitions from 1, 1 would be the superclass. But I can obviously change that all around if I were to do it again. So yeah, void is a method or a function that doesn't return anything. So you notice how here, if I have public int 2, it returns a 2. If I have public string toString, for example, like this is what we learned last, I'll return a 2. So this is basically returning whatever return type is here. So void means there's no return type. So you don't need to return anything here. There's no return statements in my function, but I can just print out or do some computation or whatever. Yeah, there will be a review at the end.
Excuse me, could you go over the string to string? What exactly does that imply?
Oh, so this is just a quick example that I was showing. This is like another return type. So notice how there's a return type void here, which means return nothing. Then I have return type integer, which returns like a number. So in this case, 2. And then toString is just another method I created that returns a string. So I returned a 2 like that.
So you're basically not returning the 2 as an integer, you're returning it as a string in that very second line. I see. But then is that necessary? But you can do it either way, right? You can either like release it as an integer or return it as a string.
Just for an example. Yeah, it's not really necessary.
Oh, okay.
Yeah, so void means you don't have to return anything.
And will you,
it's not
will
really
you
you don't
review
have
what
to,
this
you
code
can't
does at the
return
end?
Sorry, what?
Will you review what this code does at the end?
Yeah.
Is it possible just to go back one last time to main.java?
Yeah, I was just gonna go there. Okay. So yeah, so notice how we called print hello, print by 1, and then same thing. If I called 2.1, this will basically see 2, and it so basically I'll kind of walk you through what this process is doing. So when I create this object 2, so it goes to my 2 class. It creates an object. Okay, there's no constructor, so I'll just default create an object that can access all these methods. And then I call 2.print hello. So now it checks. We already went through this. It finds a print hello function in here and then calls a super version, then adds another print statement. So it prints out multiple things. And then it calls 2.print by. So now if I look in my 2 class, I'm looking, is there any function called print by? No. So I'm like, so now Java says, okay, let me look at my superclass. And then now it looks at the superclass and then it is able to print by because it finds a function print by. So this basically allows you to pass down functions through parent classes or superclasses or whatever. And then same thing for this last one. We have 2.1. So if I go into my 2 class, is there any function named 1? No. So it goes into my superclass. And then I find this function 1. So now it should print out a 1 when I run this. And then you see it printed out a 1 this time. So when you have a child class like this 2 is called the child class, then it can access all the methods in its parent class and the methods inside its parent class. So I'll continue this example. I'll create another class called 3. And then in 3, what we want to do is extend 2. So now in this case, 3
So can you not extend 2 files?
Class, and 2 is the parent class. So 2 would be so 2 is a child class of 1, and then 3 is a child class of 2 in this case. So now what I can do is define my functions. Public int 3, return 3, and then I'll go back to my main. Then I'll say 3.print hello. So now what this is, I'll also do, just do this for now. So I'll have to compile it. So notice this is another way to compile multiple files at once. So if I just do Java C, then I can include every single file that I want to compile after it, just in a row like that. Just make sure you include spaces between them if you're running this on Sublime. So I run that, and then I can run main.java, and then you see I get hello world 3. So let me comment these out to make it a little bit easier to understand what's going on. Yeah, so we get hello world 3. So notice how I just called print hello. So the same thought process that Java is going through. It finds 3, and it sees that there's no print hello function. So it goes to its parent class, and then it sees that it's accessing the superclass of that class and then printing out world. So this is basically the same thing where it just accesses the print hello in my 2 class. So now, for example, if I were to change this to 1, so that my class 3 only extends the 1 class, and I run the same thing again. Notice how it only printed hello and 3 because 3 extends 1. So when I call this print hello function, it goes into my 3 class, and then it sees that there's no print hello. So now it goes directly into my one class, and then it prints whatever is defined over there, which in this case is just hello.
What does extends and toString mean?
So extends, remember, is what we use to get the superclass. So extends is basically what we can do to create a superclass, so that one, I can access all the methods in this class 1, or in this case, this class 3 access all the methods in 2. And then toString is just the name of a method. This is what I just created to print out what a 2 would look like.
Got it. No. What I mean is, you have the letters toString.
Yeah, toString. So this is just printing out what the string value of 2 would be. Yeah.
Got it. Thank you.
So now in 3, since I've changed it back to extending 2. So now what I can do is say public void print hello. And then I can say super.print hello. So this will just, remember, super.print hello takes whatever the definition of print hello is in my superclass. So in this case, 2 is my superclass. So we'll take this function definition. And then I'll add another line. I'll just call it 3. So now when you call this basically allows you to, so when this is called 3, it goes, okay, let me find my super.print hello. This is my super in my 2 class, and then it again finds a super of that, which is in the 1 class. So it'll print out hello world 3, if that makes sense. It keeps accessing the super because I keep extending a super class like that.
Can you please go back to 3.java if you don't mind?
Yeah, I'm at 3.java. And then you can also print, or I'll change, print by is what it's called. So I can do the same thing, super.print by. So notice how when I call super.print by here, it looks to my 2 class to see whether there is a print by function. So in my 2 class, there is no print by function. So then if there is no print by function in my 2 class, it will look to the super class of that. So then now it goes back to my 1 class and it will access whatever is here. So then I'll just print out again 3. And then when I run this, when I run that, we get hello world 3 by 3 and then 3. So does that all make sense about how we're accessing superclasses, how we're changing up the function definitions?
Yeah, it does make sense. It's just, I don't really get what the significance of the superclass is.
So the significance of a superclass is basically allowing you to access different methods from another class. So you can basically change those implementations and use those in. So for example, if I were to have a bicycle, for example, and that was my class, then you have so many different types of bikes, right? There's like a mountain bike, and then there's like a normal bike that you can like ride on in your neighborhood or whatever, just for fun. There's like motorbikes or whatever. So all of these bikes have different attributes to it, but there's always similarities between these bikes. So I have my overall bike class that I can create a motorbike or a mountain bike that basically takes values from this overall bike class, but still modifies a little bit to be for each specific bike. If that's going to make sense. We'll get more into an example like this.
So it allows you to access different similar methods.
Yeah, example. Yeah. So Caitlin wrote a good one in the class. We'll actually do something similar later today. With a square could extend a shape. So if you have like a shape class that defines, oh, I can get the area of a shape, a perimeter of the shape, and then I have a square, then you specifically say, how do I calculate this area and perimeter of a square? How do I specifically calculate this area and perimeter for a circle? Which is actually what we're going to do soon.
Excuse me?
Yeah.
It is apparently in the main.java, it's defining println as a class.
Why do you say that?
I don't know, it's coming out as a class, it's coming out green.
I mean, the colors obviously don't always mean it's a class. Like, my
Oh,
println's
okay.
blue, and so is my system. So yeah, just if you're unable to get it to work right now, I'll have the code posted after class. But
Oh,
for
okay.
right now, just
Of
follow
course.
along as best as possible.
Sure.
The GitHub link, let me get that real quick. Yeah, so that's, oops, sorry. Sent it privately to someone. Yeah, so that should be the GitHub link. Okay, so now I'm going to create, so 1, 2, and 3, this was a pretty simple explanation of how to use superclasses and how to access methods from other classes and build upon them or change them or do whatever. So remember with this, I'll just quickly show this again. Print hello, I can just change this to not call whatever's in the superclass, but completely change what my implementation of print hello is. And then if I were to call that, then you see it just prints out a 3 for calling print hello. So I changed it so it doesn't call the superclass and it just prints out a 3. And then over here you can see it just printed out a 3 for print hello. And then print by obviously printed out by and 3 because I didn't change that one. But yeah. So now going on, we're going to create another file called shape.java. So with shape.java, so as we were just talking about this, you can have so many different shapes. You can have a circle, you can have a rectangle, you can have like a pyramid, you can have a cylinder, you can have square, I don't know. There's so many different shapes you can have. So sometimes in Java, what you can use for something like that, where there's multiple different versions of it. Sorry, one quick question again. So 3, new 3. So that's basically just creating an object from the 3 class. So I'm creating, so this is saying the 3, this is my 3 class that I'm trying to access, and I'm naming this variable 3, and I'm creating a new 3 instance object of this class 3. So this basically allows me to access all those different methods in there. Yeah, okay, so now going back to the shape. So we've always been doing like public class shape like that, and then sometimes we have the public static void main or whatever. But in this case, there's so many different types of shapes you can have. So in this case, we want to use something called an interface. So this interface is sort of like a blueprint for what my different shapes are going to look like. And then I actually create a class that implements this interface to define those methods. So like when I first started coding in Java, I'm like, what is the like main point of an interface? Why do I need this? But they're basically like really important because they allow you to understand what a class does and then specifically how it does it. So in this case, this is an interface shape. And then I define these methods. For example, in a shape, I want to calculate the area and I want to calculate the perimeter. So this is how you create an interface. So notice how I'm creating a function like this, but I'm ending it with a semicolon. And now I'm not doing like these curly braces like that. Because in an interface, you basically define the different functions that you want to include in your other shapes that you're going to create in the future. And then you don't actually create an implementation for it, but you basically just define public or private, obviously in this case public because we want to access it, and then the return type, which is a double. And then if you were to have any parameters, I could have like int x, int y, but in this case, we're just going to do no parameters. We're going to keep it simple. But yeah, so this is a quick, simple implementation of a shape. So every shape has an area and a perimeter. So now I'll go in and create a circle. So this is now my public class circle. And the way that I can basically access these functions in shape is I can say my public class circle implements shape, which basically means that this class circle is going to implement the different methods that I created in my interface shape, and then I'll actually create the code for that now. So in a circle class, we'll have a radius, and then whenever you have a circle, you obviously need to include pi when you're calculating area and perimeter. So one thing that we haven't gone over is, so I can obviously create a private double like this, pi, and then set it equal to 3.14. That's what we'll use for now. But since pi, we know the value of pi is never going to change. So something in Java that you can use is called a keyword called final. And what this basically does is declare this value pi as a constant, which means that this value can never be changed or modified in any way. And the value of pi will always be 3.14. So if I'm using this value pi multiple times in my program, it makes it easier for me not to have to type out that 3.14. Not to type out that 3.14 everywhere in my program. So yeah, there is also a constant. You can import math, and then there's math.pi. And then that has your pi value that you can use. So you can use that, but in this case, I'm just trying to demonstrate what a constant is and how you can use it in a class. But yeah, so now I'll create my constructors. So I'll have a circle, and then we'll say that if the user were to create a circle and then there's no parameters passed in, by default, I want my radius to be equal to 5. Well, this is just an arbitrary number. And then now, if a radius was passed through my constructor, then I can say this radius is equal to radius. So remember, we use this keyword this. So when we use this dot radius, this is what we covered last week. It allows you to access, it basically specifies specifically which radius you want. Because we have a parameter called radius here, and then we have a class variable called radius here. So this dot radius will refer to whatever class variable is, and if I just have something like this, then it will be referencing to the parameter. So I say this dot radius, which is specific to this class variable, is equal to radius, which is whatever the user would pass. And then now I see that I'm implementing shape, so I want to implement both of these functions. So I'll copy and paste these functions real quick in here. So now I have my area and my perimeter. So to calculate the area of a circle, it is pi r squared. So pi times the radius times the radius. So now to do that, I can just say pi times radius. And that should give me the area of a circle. And then perimeter of the circle, the same thing as the circumference, which would be 2 times pi times r. So that's the definition of a circumference of a circle. And you can do the same thing, return that. And then, yeah, so these are my different definitions of the area and perimeter of a circle. So now I created my class. I have 2 different constructors. I'll review that in a second about what these specifically mean. Then I have a constant variable here that I'm using, and then a radius. So I'll comment these out for now. So now in my main function, I want to create a new circle. So we'll call this circle 1. So notice how I did not include anything inside. So by default, my circle will have a radius of 5. And then now I can say system.out.print circle1.area. And I'll do the same thing for the perimeter. So now I want to compile my circle.java and then run it. And you see we get these really long numbers, but if you were to actually multiply it out, let's see, I'll just quickly do this. pi times radius, we had 5 times 5 times 3.14. And then we got 78.5. And then again, we have 2 times 3.14 times 5. And then that gave us this. So those are both of our values for the area and perimeter. And then, so notice how we have a constructor here with no arguments. So that's what we created here. Because I didn't specify anything in my parentheses of circle. But now I can create another circle, circle 2, and then let's say I want my radius to be 15.0. So then I can call these again. So now I specify that my radius is 15.0. And then call the area and perimeter like that. So then now if I were to compile it one more time and then run it, you see I get these numbers again, and then again I can compute that really quickly. So I have 15.0 times 15.0 times 3.14, and then we get 706.5, and then same thing, 94.2. So yeah, Python. So I was like, I don't have a calculator in front of me right now. I could use Google, but that requires me to open a browser. So then I just typed Python in here, and then you can do some quick calculations on here. So if you're ever doing your math homework or anything, you can quickly use Python as a calculator. And remember, yeah, you can use quit
Wait,
or
this is
exit.
Java, right?
Oh
This
yeah,
is Java
sorry.
class.
Yeah, sorry, I was just using it as a calculator. Yeah, okay. So now we created a circle and we have the area and perimeter. So now I'll create another one and we'll call this square. So we have another class called square. And we want this to be able to implement that shape again. So now you can see how we have this overall shape interface here. And then we created a circle implementing those methods. And then now we're going to create a square implementing those methods. So now in a square, you know that all 4 sides are the same. So I'll create a simple, just one. So this will represent one side on my square. And then I will create, yeah, actually for a square, you don't need anything else. So I'll do the same thing again. I'll create 2 constructors. And then I'll say this side 10.0. So this is referring to my side of my square, and then I default create it to 10. And then I'll create another constructor. And then this time we'll pass in a side, and I'll say this dot side is equal to side. So yeah, this is the same thing that we're doing in the circle. Whatever is passed in, we'll assign it to the value. And then to create our area, we can do return. So area of a square would be just the side squared, that, and then obviously to create the perimeter, it will be the side times 4, because there's 4 different sides, so you want to add up all 4 sides together. Yeah, so this is a pretty simple implementation of square. It's easy to make.
Do you think you could revisit the circle.java just real quick?
Yeah.
Thank you.
So now I can do the same thing that we did with the circle. I'll comment these out for now. And I created a square.
Wait, so in the end, can you please like slow down and review all the tabs?
Yeah, I'll do that at the end.
So this works precisely similar to the Java code for the circle.
Yeah, so in this case, so circle, obviously calculating the area of a circle is different from calculating the area of a square. So that's why we had to change the implementation of area, that, and then
So why is it that you had to implement both the shape for both the circle and the square?
Yeah, so that's what I was kind of talking about in the beginning. So obviously this is a very simple program. And there's not much like functions to implement here, but when you're working in like the real world, there may be like 20 or 30 different function definitions. So then it's like pretty clear. And then obviously this, they'll have like comments on it. So you can see like this is to calculate area. Oops. This is to calculate perimeter. And then this basically, it just tells you like, these are different functions that you want to be able to create. And then it tells you what this function is doing. And then you actually create your class that implements that function. And obviously like, sometimes I might not implement all the functions in that, but yeah. Oh yeah, so for square, I'm calling this first constructor, the default constructor. So by default, it'll be 10.0. And then this time I'll pass the size, we'll just name it, we'll just make it 20. Just a random number. So then now I can run, I'll have to compile it first. And then we get 100. So we get 10 times 10 is the area. 40 is the perimeter. Yeah. And then 400, 20 times 20, and then 80, which is 20 plus 20 plus 20 plus 20. So yeah, these are just simple implementations of how you can do area and perimeter of a square.
Can you please go back to square?
Yeah. So are there any questions on interfaces, parent classes, subclasses, any of those terms I introduced? Why you're using subclasses, why we need to use interfaces, anything about that?
What do you mean by parent classes and subclasses?
Oh, that's what we did over here with 1 and 2. Remember how we extended 1 so that 1 would be a parent class of 2? Yeah. I don't get where you put the length of each side. So yeah, so double side. So obviously, yeah, so you guys know in a square, every side is the same. So I just created one variable to represent whatever one side it was. So then you know that this side will represent all 4. So then if I'm calculating the area, it's just those sides times each other. And then the perimeter is just all those sides together. So size times 4, same thing as doing like size plus size plus size plus size. Oh, side, sorry. Because that's how you calculate the perimeter of a square. Yeah, so that's what I'm going to do next. So now we'll just create a rectangle. So this will just be the same thing. Public class rectangle implements shape. I'll only do one constructor this time, and we'll take in a double. So we have in a rectangle, we have a length and a width. And then we can pass those into our constructor. And then we can say this dot length, this dot width. So this is my constructor, and then I can do this really quickly and then do length times width as my area. And then my perimeter would be, we can add a couple more lines for this. We can just say, or return double. Actually, no, I'll just return it all in one line. So this would just be how to calculate the perimeter of a rectangle. 2 lengths plus 2 widths, which is the same thing. Oh yeah, so this is a good question. This is something that we went through last class. So we have a public class rectangle. So obviously that allows me to access my rectangle class anywhere outside of this class. And private double length and private double width, that basically ensures that no one is modifying the length and width of my rectangle outside of my class, and that everything in here is basically this length and width are specifically to this class, so that I can't change those length and widths unless I actually change these values in another method. But yeah, private basically means strictly to this class, this rectangle class in this case. And 5.0. So yeah, so I passed in a length and a width for my rectangle, which had the values of 10 and 5. And then I printed out the area here, and then I printed out the perimeter here. Then I can run that. Yeah, so just look at the last two values. I'll just comment it out. And then we got 50 and 30 because the area would be 10 times 5. And then the perimeter would be 10 plus 10 plus 5 plus 5. So what is the difference between class, object? Okay, so Caitlin has a good explanation there. So can you do this with 3D shapes? So yeah, you can do this with 3D shapes. It would just cause me to write more code. But yeah, I would have to, if I can name this 3D shape, and then I can have a bunch of other methods, like for example, like get height or something, get width, depending on my shape. But yeah, you can do this with 3D shapes. Okay. So yeah. So we were able to get through all of that. Okay, yeah, so now I'll start with the review. And then if we have a little bit of time at the end, you can either ask questions or I'll just do a couple of other examples relating to previous classes, reviewing some material from previous classes. But yeah, so we first started out with creating this class 1. And this class 1 is just a normal class that we've always been creating. And then I implemented these 3 different functions, print hello, print by, and 1. So remember, void has no return type, and then this has a return type of integer, so I returned 1 like that. But then notice in these two, there was no return statement. And then I was able to just create 1 and then print out all of those using the functions that I created in the class. So I created a 1 object, then called those 3 different functions. So now after that, what we did is we created a public class 2. So a new class 2 that extends this class 1. So it extended this class, and remember when you include this keyword extends, then it basically takes all the methods that I implemented in my 1 class and allows me to access them through my 2 class. So print hello like this, I called the same function, I created the same function that we created in class 1, and then I called super.printHello, which basically tells Java, look back at my class 1, find what my implementation of print hello is, and take everything inside and basically put it where it is here. So for example, if I had more lines like this, like something random, then it would also print that out when I call this super. So yeah, so it just takes everything inside that, and then I added another line just to make it different. And then I created an integer 2, similar to how we created 1 over here. So this is just returns a 2. And then I was just demonstrating how to return a string. So notice void return type, integer return type, and then string return type. This is not relevant to classes and implementing classes or extending classes, but this is just another way. And then I went back to main. And then notice how I called print hello, print by, and I'll change this back to 2. So 2.printHello, remember it sees, okay, I have this object 2, so I'm going to go into my class 2, and then do I have an implementation of print hello, and then it'll print out whatever is over there. And then same thing, so now for print by, it goes back into my to class, and then there's no implementation of print by. So it goes back, you see it extends one, so it goes back into my parent class and finds that implementation of print by and then calls that. So now it printed out by, like that. I'll show you in a bit. And then 2.2, that will just call 2 over here and we'll return a 2. And then, yeah, so we have the output like that. Hello by 1, hello world by 2. So then we created a 3 class. So that extended the 2 class. So the 2 which extended the 1. So if you were to kind of draw this out, the tree would look like 1, which is the parent. Then it's hard to draw down arrows on or type out down arrows, but 2 would be the like, intermediate child, and then 3 would be the child. So this is a child of 2, of 1, and then this is a child of no one, it's the parent. So yeah, that's quickly how it is. So then now I extended 2 and I did a print hello. So notice in this print hello, I did not call this super.print hello. So it basically just overrides whatever the previous declaration of this print hello is, and then it printed out 3. And then print by, this is taking the super of, so it finds my super class 2, then it sees, is there a print by definition? No, there's not. So it goes to the super of 2, which is 1, and then sees the print by is there. So when I call super.print by, it basically retraces through 2 and 1, and then finds this line, and then prints that out. So it will print out by, and then 3, and then this is just the same thing that we implemented before. So now when I create this function 3, I'll call print hello, print by. So when I call print hello, it goes 3, and then it just first takes out whatever it finds. So since it's not calling any superclass or anything, it's a pretty simple call here. And then I call print by, and then that will take the super and then print out whatever is here. So then now I can run that. So then I get 3 by 3, and then obviously the number 3. So yeah, so that was quickly how we did inheritance, how you can use super classes, parent classes, same thing, and then child classes to access different functions and modify them. So yeah, and then I'll comment that out. So then what we did is we learned what an interface is. So here is an interface, and I was saying that this basically just defines what you need to include in your different shape classes, and then it has like, usually we'll have like a quick description on what this function is doing and what you need to implement. So we created this circle class, and then I used the keyword implements to basically get those function definitions from shape. And then I created a private variable called the radius, because every circle has a radius. And then we learned this keyword final to define a constant. So I'll actually quickly show you guys. If I were to try to change this, for example, to 4.0, for example, like some case, let's say the value of pi changed, and I try to compile it, then you see Java throws me this error, cannot assign a value to a final variable pi. So it's basically saying that this is, Java's telling you, okay, you declared this as a final, which means you don't want to change it. Why are you changing it? So you can't really change a variable with the final keyword. And yeah, so what I did was I created a default constructor that set the radius to 5, and then another constructor where you can pass in the radius. And then we use the definitions, area and perimeter from our interface, and then actually define what those are doing for a circle, and then returned that value and returned that value. So then now when we run it, we get all these different values. We're not going to be able to calculate that because of pi, but yeah. We passed in the 15.0 as the radius using the second constructor. So notice how we use 2 different constructors here. New circle with empty parameters, and then new circle with 15.0. Yeah, so that was a circle. And then we went on to square. And with the square, again, we implemented shape to implement the functions that were defined there. And then I created a side because every side on a square is the same. And then by default, we set the side to 10. And then if they were to pass, the user were to pass something, then that was through a parameter here. Then we implemented area by multiplying the sides, obviously, and then perimeter, which is all 4 sides added together. I'll change this back to side times 4. And then we can run that. Yeah, so then we get all of these outputs with the area of the original square with the value 10 and then with the value 20. And then lastly, that was the same thing we did for rectangle. So that implemented this shape. And then we created 2 private for length and width of a rectangle. And then we passed in 2 different values into this rectangle constructor because a rectangle requires these 2 values. And then, yeah, then we created these area and perimeters, which is the same thing, length times width, or length times 2 plus width times 2. And then we ran it to the main file. And we got our values 50 and 30 because 5 times 10 is the area, which is 50, and then 5 plus 5 plus 10 plus 10. Yeah. So yeah, so that was a pretty quick way to teach interfaces and inheritance with parent classes. But yeah, so next week we'll be using this more along with obviously everything else we've learned in this class so far. But yeah, it's 6 o'clock. So if you guys need to go, feel free to go. The video will be posted online. But if you have more questions about this topic, I'll stay here after to answer any questions. Yeah, thanks for coming. Yeah, so next week's class will be the last class. So how, so with Sublime, yeah, the tutorial is online on exactly how you can run it, but if you use the Java keyword, you can run whatever file you want, but you can only run files that have the main method as we've talked about. If it does not have this main method like this, then you cannot run a Java file. So for example, I can't really run, if I were to try to like run circle.java, then yeah, it'll give me an error.
Yeah, I have a quick question.
Mm-hmm. Yeah.
You have square as the name of the class, and also you have 2 squares as name of constructors.
Okay.
How do you distinguish?
So yeah, so the reason I did that was, so yeah, obviously square is the name of my class. And then the name of your constructors, as we've talked about, is always the same name as your class. But in this case, I did 2 different constructors. So this first one would be the case where there is nothing passed in. So notice how when I called these square over here, one of them I passed in a 20.0 and then one of them I kept empty. So when I keep that empty, it's basically referring to this constructor, meaning by default, basically saying that no value for this side was passed. So I'm going to default this value to 10. But then in this case, I actually passed in a 20. So then it says, okay, so something was given to my constructor. So now I can assign this value side to 20.
Does the name of the constructor have to be same name as the class?
Yeah, it does.
Okay, thanks.
Mm-hmm. Cool. Okay. Yeah, so if there are no other questions, I will see you guys next week in our last class. Thanks for coming.